So we talked about the algebraic numbers last time and did some operations with them, combining them and all that good stuff. We talked a little bit about translating words into those phrases. Things like oh, 8 times a number is 32. Actually, this is taking it one step further than what we did on Monday. We still have to translate the words into expressions, but there's going to be something extra here. Take it piece by piece. 8 times a number is 8 times x or 8 times n or whatever we're going to use. Yes, so we'll go 8x. We could have 8 times x or we could just have 8x. They both mean times. Is 32, what does that mean? Yeah, is means equals 32. Generally, we write it that way. We don't put the times in between a number and a variable just to save some space. Or we might have 12 more than 5 times a number is 84. So looking at this, again, we're going to go piece by piece. 12 more than means we're adding 12 to something. 5 times the number is 5x, 5n, whatever number we're using. The 12 is being added to that, so the 5x goes before the plus 12. And then we have is 84, which is equals 84. You getting better at those? It's just a matter of slowing down. And one thing I always recommend to people, once you write it out, try to take this and translate it back into words. So this is 5x plus 12 equals 84 is what you'd say. Well, does that give you the same thing? Does that mean the same thing as what's written here? Is 12 more than 5 times the number? Is that the same as 5 times the number plus 12? Yes, it is. So compare them back and forth and see if, once you've got this written out, make sure this makes sense according to those words again. Okay, so anyway, the main point for today is to work with things that look like this. Of course, that's called an equation. All equations start out in this form as a variable equals a number, or the other way around, a number equals a variable. And they're built up from there. So we're going to start out with them in this simplest form and start working from that. To understand how these work, we need to understand this symbol right here, which is the equal sign. What does it mean? That's a tough one. It means equals. What it means is that what's on one side has exactly the same value as what's on the other side. In fact, you can think of it as a balanced scale. What's on one side of the equal sign exactly balances what's on the other side of the equal sign. And as I said, all equations start out in this form as a variable equals a number. And they're built from there. One of the things we could do to build onto this, we might add 5. So now this becomes x plus 5. But if we're not careful there, if we add 5 to one side, the scale's going to tip, isn't it? How do we keep the scale from tipping? We have to do the exact same thing to the other side. So in this case, we have to add 5 to the other side. 9 plus 5 is 14. So if x equals 9, x plus 5 must equal 14. We just built an equation. Now, if we are ever asked to solve an equation, what that's asking us to do is take that equation back apart. Well, this equation was built by adding 5. How would we reverse that? How would we take that apart? Subtract 5. Takes that piece off, and we're left with just x. Now, like we said, we have to keep this equation balanced, or the scale balanced. So whatever we do to one side, we have to do exactly the same thing to the other side. We subtracted 5 here, we have to subtract 5 over here. 14 minus 5 is 9. X equals 9. That's what they're asking you to do when you solve it. Take it apart and get it back to where it started from originally. Well, this one, we built it ourselves, so we know how it was built. So, it was really easy to take it apart.
But when it says solve, it doesn't want it.
Yeah. Well, this is the answer. X equals 9. It's asking you to take it apart and get the variable on one side and a number on the other, so you know what the variable is equal to. Like I said, this one, we built it. We watched it be built, so we knew how to take it apart. It was pretty obvious. The trick is figuring out how it was built in the first place. Like we might have y minus 7 equals 8. To figure out how it was built, we just find the equal sign. Then we identify which side of the equation has the variable on it. It's over there. Then, since we know we want to get it to a form where the variable equals a number, we want to get that variable by itself. So we're going to ask ourselves, what's keeping the variable from being by itself over here? The 7. What operation was used to build that onto the equation? Well, here the 7 was subtracted. So to take it apart, we're going to add 7. That removes that subtracting 7. Leaves us with just y. Now again, because this is a balanced scale or a balanced equation, whatever we do to one side, we have to do exactly the same thing to the other. We added 7 over here. We must add 7 over here. 8 plus 7 is 15. So y equals 15 is the solution to that equation. Now, if we're not sure of ourselves, we can always double check. If this is true, we should be able to come up here, remove the y, and replace it with 15, and it should give us the same value on each side of the equation. Well, this side's just 8. We put 15 in here for y. Does 15 minus 7 equal 8? It sure does. So we have 8 on both sides of the equation. So we know this is true. Y is equal to 15.
Down below that is just a longer version than what it would obviously be up on top. What you just did is kind of common sense.
Yeah, if you're looking at this, yeah, most people can look at this and just say, hey, if 15 minus 7 is 8, so 15 must be the right answer.
Right. Okay.
But we're going to run into equations that are more complicated. And once we get there, yeah, we'll have to do a few more steps to get to the answer.
Okay.
Another example might be like 7z equals 56. Again, we find the equal sign. We identify which side is the variable on it. It's over there, the 7z. What's keeping the variable from being by itself? The 7. What operation is used to build it on? It was multiplied. So to get rid of it, we're going to divide by 7 to remove the multiplying by 7. So that leaves us with just z there. On the other side, we must divide by 7. 56 divided by 7 is 8. So again, those first couple have been pretty easy. It's just been a single step. One thing's been done to build them. But they do get more complicated. We might have 3x minus 7 equals 26. So for here, this one, we go through the same steps. Here's the equal sign. Here's where the variable is. Now there are two things keeping the variable from being alone. There's the 3 and the 7. What operation was used to build the 3 on? It multiplied, and the 7 was subtracted. So to figure out how this is built, we refer back to our order of operations to figure out what was done to the variable. So in this case, what was done to x. Order of operations would be multiply first or subtract first? Multiply first. So when this was built, x, the variable, was multiplied by 3. Then 7 was subtracted from it. Now, if you put something together, whether it's a toy for your kids or a piece of furniture or shelving or whatever kits you get, if you've just finished putting it together, you've just put on that last piece, if you need to take it apart again, what's going to be the first piece to come off? The last piece that was put on. So when this equation was built, the last piece that was put on was subtracting 7. What's the first piece that we're going to take off to take it apart? The 7. How do we get rid of it? Well, it was built on by subtracting. We're going to take it off by adding. So we're going to add 7, which takes that piece off, leaving us with just the 3x. Now again, whatever we do to one side, we have to do exactly the same thing on the other side. So we're going to add 7 over here. 26 plus 7 is 33. Now we have to get rid of the 3. It was built on by multiplying. We're going to remove it by dividing. So the 3 is gone. We're left with just x. Again, we do the exact same thing to the other side. 33 divided by 3 is 11. To double check that, we put 11 in where the x was up here. 3 times 11 is 33, minus 7 is 26. So it's true. So for an equation like this, here's our equal sign. What are we going to do first? Careful. Yeah, when this was built, what was done to the y? The first thing that was done is it was multiplied by 5, and then 2 was added to it. When we take it apart, though, we take off the last piece first. So the first piece that's going to come off is the 2. That was the last piece put on. So to take off adding 2, we're going to subtract 2. 17 minus 2 is 15 equals 5y. And then divide by 5. Y equals 3. And you guys get the picture by now. You can come back up and put it in here for y and make it work. And hopefully you get 17 on this side as well, because there's 17 on the other side. Any questions so far? Okay. Well, I'm going to give you guys one to try. I'm going to pause the recording and give you guys some time to try that one in your notes. Okay, let's solve this one. So our first step would be add 9. So 4z equals 45. And as I mentioned, I screwed up. That should have been a 35 instead of a 36. So this is going to come out to be ugly, but we're going to divide by 4. So we get z is 11.25. Let's give you one that actually works out. Let's try this one. 59 equals 7y plus 3. I'll pause again and let you guys have fun. So in this one, what are we going to do first to take this apart?
Take away 3.
Subtract 3. So 56 equals 7y, and then divide by 7. Cool. So 8 equals y. Well, that's not so bad.
Right.
So now let's look at some things like this. We're looking at this one, and what sticks out at us?
There's
Oh.
two x's.
There you go. The x appears twice. So, we have to figure out what to do with that. We can't solve an equation that has two x's in it. But when we look at this, we find our equal sign, and we see that both the 5x and the 2x are on the same side of the equation. Even if we're thinking of that balanced scale, they're on the same side of the scale, which means I can take them and I can just push them together into one big pile, and it's not going to change how my scale balance is.
So 7x?
Yeah, so 5x and 2x make 7x. We have minus 1 equals 62. Now we can just solve it. What do we have to do? Add 1, 7x equals 63, and divide by 7. X equals,
Take it that way, right?
you got it. looking at this one now, the x appears twice in this equation as well. What's different though? Yeah, we find our equal sign right here. And we realize that one x is on each side of the equation. Since one's on each side, we can't just push them together and combine them anymore. So what we have to do is we have to get rid of one of them. Literally grab onto it, pull it off, and throw it away. Well, mathematically, how do we do that?
We subtract.
Subtract it. You got it. And what we're going to do is we're going to subtract or take away the smallest one so that we end up with positive numbers. The smallest one is going to be the 3x, so we're going to subtract 3x. That means we've got rid of it. It's gone from that side. All that's left over there is positive 18 or 18. But if we take 3x off of one side, we have to take it off of the other side as well. Where do we take 3x's away from this other side? From the 5x. So 5x, take away 3x, or 5x minus 3x is 2x. We still have the plus 4 over there. So that becomes 2x plus 4 equals 18. And then subtract 4. 2x equals 14. And divide by 2. X equals 7. What's that?
Okay, that was a little fast.
Okay.
Okay.
So you had to take away the 3x to get rid of one of the x's, right?
Yeah.
So 5 minus 3 leaves us with 2x over here.
Okay.
Now we have to subtract 4 to get rid of that. Subtracting 4 over here gives us 14. So 2x equals 14.
Mm-hmm.
We have to get rid of the 2, so we divide by 2. Divide by 2 over here gives us 7. So looking at this one, oops, I did something wrong there. Let me fix that. What do I need to do first? I can combine them. The 2x and the 4x are on the same side, so I can just combine them to get 6x plus 4 equals 34. Now what do? Subtract 4. 6x equals 30. And then divide by 6. X equals 5.
But you're like missing. Something seems wrong because there's 2 addition signs over there.
Over here.
Yeah.
But when we combined the 2x and the 4x,
Yeah.
one of them's gone. Because remember, this is all this here means is that this is a positive 4 and that this is a positive 4x.
Oh.
So we've got 2x and positive 4x make the 6x, and you still have the positive 4. So there's really only one addition sign left over.
Okay.
So remember, these operations that are in front of the numbers go with the number that comes after them, and it's telling us whether it's positive or negative. I mean, it is adding and subtracting, but it's also positive or negative.
Yeah.
It'll take a while to get used to. So on this one, where do we start?
Okay, so that's a minus 26 and a minus 2.
Yes. Or you can think it was a negative 26 and a negative 2. Either way, whichever's easier for you to think of. Well, we've got 5x and we've got 9x. We need to get rid of one of them or combine them somehow. What do we need to do here?
Negative 4.
Well, we can't combine them because they're on opposite sides. So we have to get rid of one of them.
Yeah.
Which one do we?
Because of 5 makes the
Yep, so we get rid of the 5x by subtracting it. It's gone. We're left with negative 2 here. And yeah, we do. If we take 5x from one side, we have to take 5x from the other side. 9x minus 5x is 4x. We still have the negative 26 or minus 26. Now what?
So would you take the minus 2 and make it,
Well, here's our variable, so we got to get rid of everything that's built onto that side of the equation. So it's the 4 and the 26 we have to get rid of.
okay.
So the 26 was subtracted, we're going to add 26. So negative 2 plus 26 is negative 2 positive 26,
Oh,
24. So 24 equals 4x, and then divide by 4. Perfect, you divide by 4. So 6 equals x.
and then,
What's that?
I'm getting really confused.
Oh, these, we're going to come back and look at more of these as the days go on. Yeah, because there gets to be a lot of different possibilities you have to keep straight. So let's have you guys try one. So we've got 5x plus 7 minus 2x equals 20. So I'm going to pause this and give you guys a little bit of time. So let's take a look at this one. We'll go as far as we can. I messed this one up too, but the steps are still going to be the same. What do we do first? We have 5x and a negative 2x, which make 3x. We still have plus 7 equals 20. And then subtract 7. 3x equals 13, and divide by 3. 4.3333.
Oh, well, what do I do?
That's the same thing. Remainder of 1. 13 divided by 3 would be 4. That's 12 with a remainder of 1. Let me try to give
So
you
why
a...
is that you get different, okay, so why is that they get 4 remainder of 1 and 4.33?
They're the same thing. It's just the calculator, when you do 13 divided by 3, it doesn't give you a remainder. It just divides out.
Okay.
Calculators don't do fractions.
Well, they'll give you it as fraction if you've told it to do it as a fraction.
Yeah.
Okay, let me try to give you one that works.
So both of those answers would be right,
Yeah, either one of those would be right.
not on the computer, but.
Yeah. Like 4 remainder of 1 would be right, or 4 and 1 third would be correct as well.
Okay.
And so would the
Oh, right, okay,
4.3333.
that makes sense, yeah.
Oh, let's see what I can do here. Here, I'll pause this and let you guys solve this one. So, first step. Got to combine the 7 and the 5. How are we going to do that? Got to subtract the 5x. Here's a positive 14, or just 14 over here. Subtract 5x over here gives us 2x, and we still have the minus 2. And then add 2. So 2x equals 16, and finally divide by 2. X equals 8. And of course, as always, we can double check these. We can take the x up here and replace it with 8 and see if it works. What's 7 times 8? 56 minus 2 would be 54. 5 times 8? 40 plus 14 would be 54. So we have the same value on each side of the equation, so that tells us we did it right. So you can always double check your answers if you're not sure.
But there are some instances where at 7, surely 1 equals 0.
Since Cody wants to harp on that, we'll talk about that quick.
Yes.
Here's a little extra credit opportunity for you. I want you to find and tell me what's wrong with this. Except for Cody, since he obviously already knows it.
Shoot. It was my
We're going to build an equation here. We're going to start out with the equation that x equals 1. And what we're going to do to it is we're going to multiply both sides by x. Is we can multiply both, if we do exactly the same thing to both sides of an equation, it's okay. What's x times x? X squared. What's 1 times x? X. And this still works since x is 1, 1 squared is 1, 1 equals 1. So that's still good. Now we're going to subtract 1 from each side. So x squared minus 1 equals x minus 1. Now I'm going to take this and I'm going to split it into two pieces. We talked about multiplying a little bit yesterday, or on Monday. Let's say we did x plus 1 times x minus 1. If we were to multiply that out, negative 1 times 1 is negative 1. Negative 1 times x is negative 1x. X times 1 is positive 1x. X times x is x squared. So we've got a negative 1, negative 1x and positive 1x is 0. It cancels out, and x squared. So x plus 1 times x minus 1 is equal to x squared minus 1. So I'm just going to replace that. So x plus 1 times x minus 1. I'm putting in place of the x squared plus 1 equals x minus 1. Now, I'm going to divide both sides of the equation by the same thing. I'm going to divide by x minus 1. On the right side over here, it's just x minus 1 divided by x minus 1. Well, anything divided by itself is 1. Now over here, the x minus 1 divided by x minus 1 is 1. It leaves me with just the x plus 1. Now again, doing the same thing to both sides, I'm going to subtract 1 from each side. X equals 0. But we started out with x equals 1. So therefore, if x equals 0 and x equals 1, well then 0 must equal 1. Obviously, there was a problem with what I did there. The question is, what was it? It's a good place to take our break. So let's go ahead and take a break. We'll come back about 9:30 and we'll start up again.